Hi, today I will be talking about Stephen Hawking, his life, his scientific discoveries, and his legacy. So, who was Stephen Hawking? He was an astrophysicist and a cosmologist. These two things initially sound very, very similar. However, according to Merriam-Webster, the Merriam-Webster dictionary, an astrophysicist studies how the universe behaves, its phenomena, and its physical properties, whereas a cosmologist studies the natural order of the universe. So they're slightly different. He was an author of many books, even some New York Times bestsellers. And he was the father to three children, including Lucy Hawking, who was a co author on several of his books and wrote her own children's books as well. So here's a artist rendition of a black hole. Black holes were one of the things that Stephen Hawking was very influential in. He defined we've all heard of a black hole in some form or another. But Stephen Hawking defines them in his book Brief Answers to the Big Question as a star that has collapsed in onto itself and is absorbing everything around it. The gravitational pull on these things can be so strong that even light itself does not escape it. Originally, a black hole, another term for them was cosmic censorship. And personally, I like that term better. It just sounds cooler. But Stephen Hawking studied these quite a lot. And when he first was getting his PhD, the black hole research was very young. There was very few people researching it, and many people didn't even believe that black holes existed. Even throughout near the end of Stephen Hawking's life, many people still did not fully believe that black holes were real. But one of the things which Stephen Hawking had a large influence on was called Hawking radiation. It was actually named after him. Now, if you look at the artist's rendition on the screen, you'll see there's a glow. That glow is called Hawking's radiation. And basically what that is when two particles that are conjoined start to enter into the black hole, they break apart. One will always get absorbed in, and the other one could not get absorbed in and go float around space for all infinity, or it could get absorbed in as well, which is more likely. However, this one that escapes every once in a while will end up creating a glow, which is known as Hawking radiation. This radiation was so influential because it ended up proving that black holes could shrink in size and collapse, and that the gravitational pull was not always enough to pull everything into it. When Stephen Hawking first studied this, he believed that they only got larger, but his research ended up proving him wrong and showed that they could get smaller. And this has produced many questions for scientists, such as where everything that was absorbed into the black hole goes. When it's gone, what happens if the black hole collapses? Is that information lost forever? Or does it somehow get spit back out? We don't know yet, and scientists are still studying it to this day, trying to figure it out. Another place that Stephen Hawking did a lot of research was into the Big Bang. And if you look at the two graphs on the screen, the first one is the original Big Bang model, and the second one is Stephen Hawking's model. And we'll describe this little bit of differences in a moment. So the Big Bang was originally proposed by physicist Father Lamartine, who proposed the first Big Bang model, which is the upper one. Now, in an article published by the American Museum of Natural History, he was not well accepted for this and faced a lot of criticism from fellow scientists for believing in the Big Bang. But as he continued to develop his theory, most scientists ended up believing him. So If we look at the state scale, it shows that there was a definite point in which the universe started expanding, and it just rapidly expanded out and out and out forever. Now, Hawking describes this in his book, the same one I referenced earlier, Brief Answers to the Big Questions, as a balloon. And if you put a dot on the balloon and another dot on the balloon, and you blow the balloon up, it will expand, and these dots will get farther apart every single time with every single breath, and they just get farther and farther away. And that's how he describes the Big Bang. Hawking instead proposed the no boundary proposal, which is the lower one right here, which instead of saying there was a definite point in which there was only one atom, or as it's called, singularity, it never entirely reaches that point. It just gets smaller and smaller and smaller until forever. And the universe is always expanding out. Now, we do know with both models, the universe is constantly expanding. And we know that that is true. But the issue with the no boundary proposal was the fact that it also proposed that there was an infinite amount of universes that came from the Big Bang. Not one, not a handful, an infinite amount. And the problem with infinite amounts is they are very hard to study. When you don't have one, you have so many that you could never count. It's very hard to study it and narrow the theory down to a reasonable amount. For this reason, a few months before Stephen Hawking passed away, he proposed the new boundary, the new no boundary proposal, which narrowed it down a little bit more and only allowed for a handful of other universes. This study is so new into what will become of the new model that I can't really make a statement on it, but we know that it will definitely be studied, and only time will show how well these theories hold up. And that was also from the Quanta magazine. So the next reason why I think Stephen Hawking was important, and probably one of the largest reasons, was because he was an author. He wrote many books that I've read and many books that I have yet to get to. One of them is The Theory of Everything. This is my personal favorite. I've read it 2 times now, and I hope to read it again soon. It was incredible. It really makes you think a lot. The theories he proposes in it and the information he shares really changes your mind about a lot of topics. A second one he wrote, which is Brief Answers to the Big Questions, I have here with me today. This was the very first Stephen Hawking book I read. In fact, it was one of the first science books I read outside of high school classes. And lastly, another one of the books I am starting reading is The Grand Design. So far, it's been really very, very good, and I would highly recommend you read any and all of them. So a little bit about the legacy that he has left behind. He was known as one of the greatest minds in science. When we think of science, especially the big names, we think of Albert Einstein, we think of Isaac Newton, we think of Stephen Hawking, and Neil deGrasse Tyson. All of them were humongously influential on science and will continue to be. He's a popular culture icon. Icon might be pushing it a little bit, but I like to believe he is. And he was on shows like The Big Bang Theory or Simpsons. He never seemed to shy away from being in front of the camera if it meant that he could share a little bit of his passion with the world. He produced many groundbreaking theories. The theories that he proposed, only time will tell how much they will actually change our world. And he brought such advanced theories to normal people. When I first picked up this book at the library and I flipped through it, I was worried that I wouldn't be able to read it because I wouldn't understand what he was talking about. I've attempted to read scientific papers before, and the jargon makes no sense. The mathematical equations don't mean anything to me. But Stephen Hawking wrote it in such a way that I could understand it. And he even made me laugh many times throughout it. One of the chapters in here is entitled, Can We Time Travel? Is it possible? And in it, he talks about the time he threw a time traveler party and he invited everyone 3 days after the party existed. No one showed up to the party. And so he says he's not sure if that means that time travel doesn't exist or if he just wasn't interesting enough for time travelers to come visit him. So I just wanted to end it with a quote, which he says his goal is simple. It's to completely understand a complete understanding of the universe, why it is as it is, and why it exists at all. And I just love the way the quote is, and I think it's a great way of looking at our life, to live life trying to understand as much as we can. And these are my works cited. Thank you.